And once again, read the message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, today we're going to cover section 7.3, but first, if you have any questions from section 7.1 or 7.2. So let's start off. Do you have any questions from section 7.1?
I do have questions on 7.1. I have 3.
Can you just read them to me, or do I need to look at
it? Yeah, so it was number 15, and oh gosh, did I write that? Oh, okay. Oh god, I don't think I wrote it down. Hold on. Okay, I have 17 written down. Okay, 17 was 16 minus 4h, and then h squared minus 16.
Wait a minute. 16 minus 4h squared minus 16?
Over h squared minus 16.
So that.
Yeah.
16 minus h squared minus 4h squared over h squared minus 16.
16 minus 4h over h squared minus 16.
So that.
Yeah.
Okay. All right. So our greatest common factor on top is a 4, which gives us a 4 minus h left over. The bottom is the difference of two squares, h plus 4 times h minus 4. Aha. Right here, we have doggies and kitties. That is, we've got the difference divided by the opposite. So those reduce down to a -1/1. So our final answer is going to be -4 on the top, h plus 4 on the bottom.
Okay, that's what I got. I just wanted to make sure I did that right.
Sure. Uh-huh.
And then it was number 19 too. So it was h and then parentheses, x. X parentheses.
Hang on. X parentheses.
X minus 16. And then end parenthesis plus 64 over 64.
The whole thing is over, or just the last part?
The whole thing. Minus x squared.
All right, so x times the quantity x minus 16 plus 64 all over 64 minus x squared, right?
Yes.
Okay, so the numerator, part of it is factored, but not all of it is factored. So we're going to have to multiply it out and then come back and factor it. So I'm going to get x squared minus 16x plus 64 on top over 64 minus x squared. But now the numerator is going to be x minus 8 times x minus 8. That's factoring this trinomial over 8 plus x times 8 minus x, the difference of two squares. So do you have any questions about how I got the factors?
No.
All right. Well, let's see. Oh, there is that -1. So x minus 8 over 8 minus x is -1/1. So I've got a negative times a quantity x minus 8 all over x plus 8, or 8 plus x. And that negative sign up top, I can leave it like it is. I can distribute it, or I can put it out front. So I could leave it like this, or I could write it as -x plus 8 over, I'm going to switch the denominator around, or I could write it like this. So I can have it out in front, I can distribute it, or I can leave it in the numerator outside the parentheses. And these should all be correct.
Oh, okay. Yeah, I didn't get that for that one.
You see how I got those?
Yeah, I saw how you got it though.
All right.
And then the last one I had was number 15, which says simplify assuming the denominator is not 0, and then it gives you 8, and then parenthesis t minus 1, end parenthesis, plus 8, all over 8t plus 8.
So like that.
Yes.
Okay. So again, I'm going to multiply out the numerator, 8t minus 8 plus 8 over 8t plus 8. Those would cancel out. So now I've got 8t in the numerator, and I can factor an 8 out of the denominator to have a t plus 1. So factoring an 8 out of that. The 8's reduced down, and I end up with a t over t plus 1.
Okay, yeah, I messed up. I think it's because I distributed that 8 even to the other plus 8.
Ah,
64.
right. Yeah, be careful of that. Right. Any other questions for you from this one?
No, that was it.
Okay. Anybody else questions from 7.1? All right.
No, I didn't have any.
Okay. 7.2. Any questions from that?
No, I'm fine.
Okay. All right. Then we'll go on to 7.3. 7.3, we're going to look at two main things. The first is adding and subtracting fractions with a common denominator. Okay. So let's kind of review how that works with some simpler problems, and then we'll get into some more complicated ones. Let's say you've got 9 over x plus 2 over x. Adding two fractions with the same denominator, you add the numerators over the common denominator, which in this case can't be reduced. Any questions on that? All right. Adding two fractions with the same denominator, you add the numerators over the common denominator, which in this case, again, can't be reduced. Okay, let's see. Here we have b cubed minus 8 over 10b to the 4th plus 8 over 10b to the 4th. Adding two fractions, or rational expressions as they're called in algebra. A rational expression is a fraction that contains variables. So we're going to add the numerators over the common denominator. But now when we simplify the numerator, the minus 8 and the plus 8 will cancel out. So we have b cubed over 10b to the 4th. However, now we can reduce b cubed over b to the 4th and make it a 1 over a b. So we get 1 over 10b as our final answer. Is everybody okay how I got b cubed over b to the 4th as b in the denominator?
Yes.
All right. Let's see here. Y plus 2 over 10z plus y plus 4 over 10z. So we're adding two fractions with the same denominator. So we're going to add the numerators over the common denominator. Combining like terms, I get 2y plus 6 over 10z. However, I can factor a 2 out of the numerator, which then allows me to reduce the 2 over the 10 to a 1 over 5, and I end up with y plus 3 over 5z. Any questions there? Okay. 1 over h squared minus 4h minus 5 plus h over h squared minus 4h minus 5. Adding two fractions with the same denominator, we'll add the numerators over the common denominator. Okay, I'm going to take the 1 plus h and I'm going to write it as h plus 1. Is that okay? It just bothers me not having it in standard form, but we could have left it that way. Factoring the denominator, whoops, there we go. Let's see, that's going to be a minus 5 and a plus 1. H plus 1 over h plus 1 reduces to 1 over 1. So now I've got 1 over h minus 5. Any questions there? Okay. 8x minus 7 over x plus 3 plus 2x plus 37 over x plus 3. Adding two rational fractions with the same denominator, add the numerators, 8x minus 7 plus 2x plus 37 over x plus 3. Combining like terms, we get 10x plus 30 over x plus 3. I can factor out a 10 on the top and get an x plus 3 as a factor on top. And I have an x plus 3 as a factor in the denominator. Those reduce to 1 over 1. Final answer, just 10. Questions on this? Okay. Now, here's where things get tricky. Let's say I've got 5x plus 8 over 3x plus 15 minus 3x minus 2 over 3x plus 15. Subtracting two fractions, you find the difference of the numerators over the common denominator. Now, here's where you've got to be careful because you're subtracting this entire numerator. So I'm going to have 5x plus 8 plus, or excuse me, oh boy, hang on. Come on. There we go. Minus the quantity 3x minus 2. So I've got to distribute that subtraction sign. Now, back here with an addition sign, if you put it in parentheses, distributing the addition doesn't change anything. So I didn't need it there. But here, you're subtracting all of that. So I end up with 5x plus 8 minus 3x minus times minus plus 2, which then becomes 2x plus 10 over 3x plus 15. And I'm still not done yet. But do you see how I've got to subtract all of that? So I've got to distribute the subtraction sign to all the terms there. That's where people mess up. Now, taking this, I can factor a 2 out of the top, and I can factor a 3 out of the bottom. The common factors of x plus 5 reduce out, and I'm left with 2/3. But I warn you, this could be your downfall, so be careful. Okay. Let's see here. 11w plus 6 over 3w times w minus 9 minus the quantity 11w over 3w times w minus 9. Okay, so I've got 11w plus 6 minus 11w. Now here, I'm only subtracting one term, so I don't need to put parentheses around it. But if this was more than one term, I'd need to group it, distribute, and go on from there. Common denominator, 3w times w minus 9. Well, in the numerator, the 11w and the minus 11w reduce out. So I have a 6 over 3 times w minus 9. 6 over 3 is 2 over 1. So I've got 2 over W times W minus 9. Or if I wanted, I could write it 2 over W squared minus 9W. So either way. Sometimes the directions will say leave the answer factored, in which case you can leave it like that. Other times it doesn't matter, but there is that. Any questions there? Okay. Let's see here. 2 minus 7n over n squared plus 5 minus negative 7n plus 2 all over n squared plus 5. So my denominator is going to be n squared plus 5. My numerator, I'm going to have 2 minus 7n minus the quantity negative 7n plus 2. Then I'm going to have 2 minus 7n, minus times minus is plus 7n, minus 2 over n squared plus 5. Wow, everything in the numerator cancels out, so I've got 0 over n squared plus 5, which is what?
Zero.
Yes. Finally, one brave soul reaches out and gives an answer. Come on, you folks. You can do this. All right. Now, we're going to talk about finding the least common denominator, because in the next section, tomorrow, we'll be adding and subtracting fractions that don't start with the same denominator. So let's say I've got this pair of fractions, 1 over 2x and 9 over 6x. What is the LCD of 2x and 6x?
Would it be 6x?
It would be 6x. Anyone have any questions about how we got that? All right. 4 over 9y and 11 over 3y. What's the LCD?
9y.
9y. Okay. 33 over 15a cubed and 9 over 10a. Careful.
It'd be 30a. 30a, right?
How did you get that answer, Mr.
That
Neal?
isn't the answer. But it's
Oh.
not 30a either. Least common denominator.
It'd be 5a.
No, it would be 30a cubed. Do you see it?
No, can you explain?
I most certainly can. All right, we're going to come back to that. Let's say we've got 1/6 plus 2/9. All right, and we're trying to find the least common denominator. What we need to do is we need to take each denominator and do the prime factorization of it. Okay, so 6 is 2 times 3 and 9 is 3 squared. The least common denominator is the product of the highest power of each different prime factor. Up there we've got 2's and 3's. The highest power of 2 is 2 to the 1 power. The highest power of 3 is 3 squared. So our LCD is 18. 18 is the smallest number that 6 and 9 both go into. All right with that?
Yeah.
Yes.
Okay, let's go back to this one. So 15a cubed is 3 times 5 times a times a times a. 10a is 2 times 5 times a. So my least common denominator, well, let's see, this is actually 3 times 5 times a cubed. We can leave it as a cubed. So I've got to have a 2, a 3, a 5, and a cubed, because I need the highest power of each different prime factor, which are 2s, 3s, 5s, and a's. So that would be 30a cubed. Are you seeing
Okay,
that?
so,
What's that?
yeah, some reason I was thinking it had to be just the A.
Yeah,
I
and
don't know.
probably what you're doing is you're confusing greatest common factor with least common denominator.
Yeah.
Yeah, I know. It's hard to keep those two straight. All right, let's see here. M, whoops, minus 21 over 12 m to the 4th. M plus 1 over 18m. So my least common denominator. 12 is 2 times 2 times 3. So I've got 2 squared times 3 times m to the 4th. 18 is 2 times 9 times m. 2 times 3 times 3 times m. 2 times 3 squared times m. So I've got to have 2 2s, 2 3s, and 4 m's. The highest power of each prime factor. So 2 squared times 3 squared times m to the 4th. 4 times 9 times m to the 4th, 36 m to the 4th. So that's the smallest denominator that these can both go into evenly. Okay with this?
Yeah.
All right. Let's see. 27 over c cubed d, 17 over 2 c squared d cubed. So my LCD, what's the coefficient going to be?
A 2,
How many c's?
3,
How many d's?
3.
Excellent. Okay. How about the rest of you? Are you getting this? I hope.
I would like to see more examples. Like I can see it, how you're getting it, but can you do another example?
Absolutely. Okay. Let's take a look at this one. B plus 1 over 5b minus 10. B over 6b minus 12. So I'm going to do the prime factorization of each denominator. 5b minus 10 would be 5 times the quantity b minus 2. 6b minus 12 would be 6 times the quantity b minus 2, which is 2 times 3 times the quantity b minus 2. So my LCD is going to be the product of the highest power of each prime factor. Well, I've got 2 to the 1 power times 3 to the 1 power times 5 to the 1 power times b minus 2 to the 1 power, because all of these have an implied exponent of a 1. So they're all of just first degree power. We okay so far?
Yeah.
2
Yes.
times 3 is 6 times 5 is 30 times b minus 2. So that would be your LCD, or you could distribute it and write it as 30b minus 60. Distributing the 30.
Yes, got it.
Okay, let's take a look at this one. Let's see. B squared minus b over 10b minus 15. 11b over 10. So I can factor out a 5 from the first denominator, and then 10 is 2 times 5. So my LCD, my prime factors are 5, 2b minus 3, 2, and 5, each to the first power. So I need 1, 2, 1, 5, and 1, 2b minus 3. So 10 times the quantity 2b minus 3. All right with that?
So since in the first one you have 5 and then the parentheses, and then on the other one you have 2 times 5, you would just count 1 5, not both.
Right. You only take the highest power. And if there's a tie, you can take either one. So like if this had been a 5 squared, I would have taken that. Or if this had been a 5 cubed, I would have taken that. But since they were both 5 to the first power, I just took one of them.
Okay, I see.
You take the highest power, not all of them, just the highest power of each. Okay. All right. Let's see here. 5m plus 6 over 4m plus 12 and 7 over 6m. So 4m plus 12 is 4 times m plus 3, which is 2 times 2 times m plus 3, which is 2 squared times m plus 3. 6m is 2 times 3 times m. Okay, so I've broken it down into prime factors. What's the highest power of 2 that's in either fraction or either denominator?
2.
Okay, what's the highest power of 3?
Would it be 1 or
Yep. What's the highest
Okay.
power of m?
1?
And the highest power of m plus 3?
1.
Okay, so now you've got 2 times 2 is 4 times 3 is 12, m times m plus 3. And again, you could leave it that way, or you could distribute the 12m and have 12m squared plus 36m, but this is fine. Okay. We good to go on?
Yes.
So if it's in the parentheses, it's its own, like,
If it's in the parentheses, what?
if it's in the parentheses, it's like its own, right? So since the m on the other side is by itself, instead of being in a parentheses with the 3, you'd count the m plus 3 by itself, right?
Yes.
Okay.
So here's the deal. This m is a factor.
Yeah.
This m is not a factor. This 3 is a factor. This 3 is not a factor, but the whole quantity m plus 3 is a factor. So you've got to recognize the difference between factors and terms. These are both factors. These by themselves are terms of this entire big factor. So yes, you're pointing out something very important. It may not seem like it, but it is. Okay, let's see. How about this one? 7 minus y squared over y squared minus 4, y minus 49 over y plus 2. So factoring the first denominator, we get y plus 2 times y minus 2. The second denominator doesn't factor any further. It's just y plus 2. So our prime factors are y plus 2 and y minus 2. I need a single y plus 2 and a single y minus 2. So there's your LCD. Because these are all of degree 1. These are both degree 1, so you can pick either one. This is the only one of those, so you obviously have to have that as well. All right. We okay on that?
Yes.
Yes.
All right, now it says build each rational expression, which is a fraction with algebra in it, into an equivalent expression with a given denominator. Okay, and here's how the problem is written out in the textbook. It says 4 over y and then 7y. What they're wanting is this. Take each fraction and write it as a new fraction with the given denominator. Okay. So the question is, what do I have to do to 4 over y to turn it into something over 7y? Well, what do I have to do to the denominator to make it into a 7y?
Multiply by 7.
So what do you have to do to the numerator?
Multiply by 7.
Right, the same thing. So your new numerator becomes 28, and your new equivalent fraction is 28 over 7y. Okay? Any questions about that one?
So you wouldn't multiply the top by 7y, right? Just by 7?
Right. What did we use? We just used a 7. If I do the same thing to the numerator as to the denominator, that's legal because 7 over 7 is just 1. So I'm just multiplying by 1. Because I didn't have to
Okay.
multiply the denominator by 7y. I only had to multiply it by 7.
Okay, I see what you did there.
All right. Well, and if you don't worry, because we're going to do plenty more. All right. How about this? 7 over y equals what over xy squared? So what do I need in the denominator to multiply by y to get xy squared?
You need to
XY?
multiply by xy.
Yeah. Because wouldn't xy times y give you xy squared? So whatever I do to the denominator, I have to do the same thing to the numerator. So I'm basically going to multiply by xy divided by xy. So now my new numerator is 7xy.
So question,
Yeah.
kind of like to Daniela's question. So anything that you're going to multiply on the bottom, you're going to multiply on the top. So you just need to find out the xy, right?
Yes. Basically, this divided by that equals that. And then you take that
Yeah.
times the top to get that.
Perfect.
Okay. Let's see here. Where did we go? Ah, here we are. 7 over 6c equals what over 30c squared? So what do I need in the denominator? In other words, what's 30c squared divided by 6c?
5c.
All right, so 5c on the bottom, 5c on the top, 35c over 30c squared is the new fraction.
And you don't want us to like factor it down, right? You just want us to leave it like that?
Right, that would be going back the other direction.
Yeah, okay.
There's a time to build, there's a time to tear down. Right now we're building. Later on we'll build and then tear down. Okay. Yeah.
Okay.
It's just a matter of what are they trying to get you to practice right now. That's coming though later. Okay. Let's see. How are we doing? Time. Yeah, one more of these. 3x minus 4 over x squared plus 3x plus 2 equals what over 8x times x plus 1 times x plus 2. So I kind of need to know what the denominator is factored so I know what I still need. My suspicion is that it's probably that. Let's see if it is. Does that give me x squared plus 3x plus 2?
Yes.
So what do I need? Good thing I can write outside here. What am I missing still?
8x.
So my new numerator is going to be 8x times 3x minus 4 all over that, which becomes what? 24x squared minus 32x over 8x times x plus 1 times x plus 2. They tend to multiply out the numerator, but leave the denominator factored. There's a reason for that. That will come up tomorrow. It has to do with when you're adding or subtracting two fractions, et cetera, et cetera. Okay, we all right with that? So now, let's see here. It says perform the operations. 3t over t squared minus 8t plus 7 minus the quantity 3 over t squared minus 8t plus 7. So we're back to adding or subtracting, in this case, subtracting two fractions with the same denominator. So I would get 3t minus 3 over t squared minus 8t plus 7. Well, it could be that that will reduce because 3t minus 3 has a greatest common factor of a 3 with a t minus 1 left over. T squared minus 8t plus 7 could be factored into t minus 1 times t minus 7. So now I can come in and reduce out those common factors and have a final answer of 3 over t minus 7. So we subtracted the numerators, we factored the numerator and denominator, we reduced out the common factors, like we're doing a little bit of everything that's been in this chapter so far. Any questions on that one?
No.
All right. How about this one? Let's see here. C over c squared minus d squared minus d over c squared minus d squared. So that's going to give me c minus d over c squared minus d squared. Now, I don't need parentheses around the d because I'm only subtracting one term. If the numerator of the second fraction was d and then some other term as well, I'd have to distribute the subtraction like we did earlier. Let's see here. Well, the denominator would be c plus d times c minus d. C minus d over c minus d reduces to 1 over 1. So I've got 1 over the quantity c plus d. Okay. Let's see here. We good to go on?
Yeah.
Yeah.
If I'm ever going too fast, stop me. I'm not in any hurry. Okay, b over b squared minus 4 minus 2 over b squared minus 4. So that becomes b minus 2 over b squared minus 4, which is b minus 2 over b plus 2 times b minus 2. And again, we can reduce out those common factors to 1 over 1, and I have 1 over, oops, let's write that a little nicer, 1 over b plus 2. I really can print legibly. It just takes a while. I get in too much of a hurry. I got an A in printing in first grade, but guess what the first C I got in grade school was? It was in cursive writing. There's a reason they call it cursive, but that's another story. Okay. Let's see here. How about this one? 10b over 3b minus 18 minus 4b over 3b minus 18. So that's going to be 10b minus 4b over 3b minus 18. Combining like terms, 10b minus 4b is 6b over 3b minus 18. But I could factor a 3 out of the denominator and have a b minus 6 left over. Now, again, I want to point out something. In the numerator, the 6 is a factor, the b is a factor. In the denominator, the 3 is a factor. The b in the denominator is not a factor. The 6 is not a factor, but the whole thing b minus 6 is a factor. It has to be a factor of the entire denominator or the entire denominator. So it has to be being multiplied by everything. So what we do have there is this 6 on top and the 3 on the bottom. That can be reduced down to a 2 over 1. So I've got 2b over b minus 6. Okay. Let's see here. Okay. Negative 4x divided by 3x squared minus 7x plus 2 minus the quantity negative 3x minus 2 over 3x squared minus 7x plus 2. So that's going to equal negative 4x minus the quantity negative 3x minus 2 all over the common denominator of 3x squared minus 7x plus 2. All right, I'll pause there, make so you can get caught up. Any questions there? All right. So now in the numerator, I'm going to have negative 4x distributing minus times minus is plus 3x and minus times minus is plus 2 over 3x squared minus 7x plus 2. Combining like terms, we have negative x plus 2 in the numerator. Okay. Now, 3x squared minus 7x plus 2. To factor that, a is 3, b is negative 7, c is 2, the product is 6, the sum is negative 7, the numbers are negative 6 and negative 1. Still with me? Okay.
Yeah.
So now I've got 3x squared minus 6x minus 1x plus 2, factoring by grouping, 3x times x minus 2, x minus 2 minus 1, x minus 2, 3x minus 1. So x minus 2, 3x minus 1. It looks like I'm done, but I'm not. Addition is commutative. So negative x plus 2 would be the same thing as 2 plus negative x, but 2 plus negative x is the same thing as 2 minus x. You see where I'm going with this?
So you're going to take out that negative 1?
Right there. That's going to be negative 1 over 1. So my final answer is going to be negative 1 over 3x minus 1. How fun was that?
Very.
Exactly. Or you could also write it this way. You could put the negative out front and have the negative sign, out in front of the entire fraction. So either way, either this or that. Okay. Let's see here. Let's do these. These are some lookalikes. So t over 12 plus 5t over 12 would be what? T plus 5t over 12, which is 6t over 12, which is t over 2. Or you could write 1/2 t. Okay? T over 12 times 5t over 12 would be 5t squared over 144. t over 12 divided by 5t over 12 is t over 12 times 12 over 5t. The 12s reduce, the t's reduce, and we have 1/5. I'm curious, they only had 3 examples. I'm going to add a 4th example. Let's do subtraction. What if we had t over 12 minus 5t over 12? That would be t minus 5t over 12, which would be negative 4t over 12, which would reduce down to negative t over 3. If I'd written the book, I'd have put that one in there as well. All righty, so tonight, 7.3, you've got adding or subtracting fractions with the same denominator, and then finding the least common denominator, taking fractions and building them to where they have the new denominator, getting us ready for tomorrow, where we're going to be adding and subtracting fractions that start out with having different denominators. So have a good rest of the day. I will be back at 1:15 should you have need of me.